Now let's come to this question. Two resistors with resistance 5 ohm and 10 ohm respectively are to be connected with this battery. Okay, so first of all what we will do is minimum current. Okay, we have to find it for minimum current. Okay, now before understanding this minimum current and maximum current, let me first see what is the condition when we do it in series and we do it in parallel. Okay, no, we will not judge now. Okay, who is going to get minimum current and who is going to get maximum current. So let's say we will talk about series first. So if we draw the series, let me draw first the circuit diagram. Now we know the voltage is here, that is here 6 volt, fine, and two resistors, that is 5 ohm and 10 ohm, clear. 6 volt, this is what we have. Now we will see what is the equivalent resistance. So equivalent resistance is 5 plus 10, that is 15 ohm, clear, and my current will be my overall resistance with equivalent overall resistance and overall voltage, that is 6 by 15. 3 2s are 6 and 3 5s are 15. So we have here definitely 0.4 ampere, clear. So in series we have seen that the current that is now will start flowing is 0.4 ampere. So here also it's 0.4 ampere, here also it is 0.4 ampere. Till this much is clear. So specific current we know, specific voltage also, specific voltage we don't know. So we will see what is the voltage here. So the first voltage, that is, this is my R1 and this is my R2. So V1 is equal to IR1, which is 0.4 into 5. So that means it's 2 volt, clear, and V2 will be IR2, that means I will be 0.4 into 10, that means 4 volts. Hence my total voltage is equals to 6 volts. 6 volts. Clear? It's easy, pretty easy. Okay, so that's all, fine. Now we will solve for parallel. We have not come to any conclusion yet. Okay, let me see what happens. So 6 volt again, that means here also we have 6 volt, here also we have 6 volt. This is my 5 ohm and this is my 10 ohm. Clear? Now we have to first find out what is the equivalent resistance, that's 1 by 5 plus 1 by 10. So my equivalent resistance will be 10 by 3 ohm, clear, that is 10 by 3 ohm. Understood all these parts, parallel combination and everything? Okay, that means now we have to find out the overall current also, that is I is equals to V by R. So what's my overall voltage? 6. What's my overall resistance? 10 and 3. So that means 1.8 ampere. Clear? Now what is the specific resistance through, this is my R1, this is my R2. Now what is my specific resistance through R1? That's V by R1, that's V is how much? We have seen V is 6, it's already given, and R1 is 5. R1 is 5. So its 5 ones are 5. You get a remainder 1.0, that means 5 2s are 10. So that means 1.2 ampere you are getting out here, and let us find out the current here also, that is V by R2, fine, that means 6 divided by how much? 10, that is 0.6 ampere. Clear? That means we have overall found out that the current that will be passing through this resistor will be 1.2 ampere, and that will be passing through this resistor will be 0.6 ampere. Clear? That means we have found a specific. Now what they are saying, two resistor with this so as to obtain the minimum current. So if you see the overall current here, that here it is 1.8. And in parallel, if you see that was parallel. In series, if you see, the overall current is how much? 0.4 ampere. So in minimum, which connection will you do then? Definitely series then, fine. So minimum, if you want to get minimum current, then what we will do? We will find out series. That means here we can just write here, first answer will be series. Clear? So why? Because in series we are able to see we are getting minimum current, because the overall resistance of the circuit is increasing and current overall will decrease. Okay, and in parallel what happens? In parallel my overall where is that current, where is the current, where is the current? Yes, 1.8, because overall resistance is getting decreased, so that means my current will increase. Clear? So that means first will be series and then will be parallel. Clear? That means this question done. Next, how will you connect the resistance in each case? So, okay, first is, okay, we have done it already. That means for minimum current, we will solve the, what we will do, we will connect it in series. Okay, calculate the strength of the total current in the circuit in the two cases. It's already done. Fine, just 2 slides and we are good to go. Clear? Okay, so next question. A resistor has a resistance of 176 ohms. How many of these resistors should be connected in parallel so that their combination draws a current of 5 amperes from a 220 volt? Now, a resistor has a resistance of this. How many of these resistors should be connected in parallel? Okay. So, before that we have to see what should be my overall resistance. So, my overall voltage is 220 volts and my so that their combination draws 5. That means my overall current will be 5 ampere. So my overall resistance will be V by I. What's my V? 220 divided by 5. 5 fours are 20, 5 fours are 20. So that means 44 ohm. Clear? Now my equivalent resistance should be 44. That means definitely it will be connected in parallel is given, but how many as such? Okay, so if I do here 1 by equivalent is equal to we don't know how many, so it's and after all of them are same, so let me keep it as 1R into X. So equivalent resistance, how much we need to possess? 1 by 44, and what's my value here? 176, and we don't know what is X. Better I will replace this letter as N. Okay, what is N? N is, let N be the total number of resistors. Clear? Okay. So N, so that means N is equal to 176 divided by 44. 4 11 4 4s are 16, 1 again 4 4 16, 11 1 4. So that means 4 such resistors we need. First of all, how many we need? N equals to 4. 2 is what? They need to be connected in parallel. Anything else they want? One of these resistors should be connected in parallel. Yeah, that's all. Okay. Next, an electric heater which is connected to 220 volt supply line has 2 resistance coils of A and B of resistance this each. Okay. So first of all, there's an electric heater. So overall, again the same story. Overall my voltage is 220 volt. Fine. It has 2 resistance coil, one is 24. Okay, both of them are 24 ohm each. Now this coils can be used separately, one at a time, in series or in parallel. Okay, we will come to this. First, calculate the current drawn when only one coil is used. Okay, so these coils can be used separately. Now we know if we have 2 resistors in parallel combination, the circuit won't be harmed, right? Because we know it is, after all, the circuit is complete. The current can flow from here and can complete the circuit. Fine. So these coils can be used separately. Okay, so in the first case only one coil has been used. That means only one resistance, let's say, has been used. So what is it? 24 ohm. Clear? What's my voltage total? 22 volt. Okay, so that means this circuit, since this is not being used, so I can do like this only. 220 volts and 24 ohm. Clear? This is 24 ohm and this is 220 volts. Right or wrong? Okay. Now we have to find out, calculate the current drawn. So I equals to V by R. So what's my voltage? 220, and what's my resistance? 24. It's fine, no? No, only one coil is used. So that means the current is that means there the flow of electrons is already banned. Now we'll solve them. 2, 6 are 12. Okay, then directly we will do like this, 55 divided by 6. So 6 8s are 48. Oh, 6 9 it will go, no? No, 6 9 is what is that? 54. I don't think so, there's no any point doing that. So this much amount of ampere will be there. Clear? Next question, that's B. B, what will solve? Coil A and B are used in series. So 220 volt here, and this is also 24, this is also 24. So in series my overall resistance will be how much? R into 2, that is 24, into 2, that's 48 ohm. Clear? This is all about my equivalent resistance. Clear? Where is it? Yeah, equivalent resistance R into 2, that is 48 ohm. Okay, what they have asked, what is the amount of current drawn? So again same story, V by R eq, 220 divided by R eq. R eq means 48. What else is left? 12, no? So 55 by 12 ampere. I'm just dropping it to fraction. Fine. So this much is when this is used in series. Okay, have I done with parallel? No, no. Okay. So now we will do with parallel. Twenty-four, and this will be how much? 220. That means 1 by 24 plus 1 by 24. How much we have? 2 by 24. So that means our equivalent resistance will be what? 24 by 2. That's 12 ohm. Understood? No, I've done reciprocal. Okay, so 12 ohm is the equivalent resistance. That means current will be voltage. It's 220, and my equivalent resistance is how much? Okay, this much. So 6 are 12, 2110. So it's 55 by 3 ohm. Oh, sorry, ampere. Fine. So we have seen in parallel my current drawn is 55 by 3. Okay, I have to change, otherwise I won't be able to compare. So that means, so I'll just drop it with this color. So the current drawn for parallel it's 18.3 ampere. Clear? Next, for series, just a second. Twelve 6 are 72. Chalo. So in this case we have in series we have how much? 4.5. We have 4.5 ampere. Clear? So for series it's 4.5. For parallel it's how much? 18.3. So that means my current overall, see again same story, overall resistance is decreasing, overall current is increasing. And what is my normal? Just a single used, 9.14 ampere. That means just single is used, that is 9.14 ampere. If it's being used in series, then it's 4.5 ampere. Okay, and if it is in parallel, then it's 18.3. Where is it? Yeah, then it is how much? How much it is then? ampere. Clear? So we can see in parallel combination the current drawn will be the maximum. Clear? Next. Calculate the total resistance in the circuit, total current drawn, flowing in the circuit. So just they are asking just the total resistance. Okay. So let us see. So whenever the resistance will be like this, we can just solve it part by part. It's easy. Okay. So first 1 by 10. 1 by 10 plus 1 by 40. That means 5 by 40. That means my overall equivalent resistance for this portion will be 8 ohm. Clear? Next, 30, 20, 60. 1 by 30 plus 1 by 20 plus 1 by 60. So the overall ratio will be like this: 2, 3, 1. 5 plus 1, 6, 660. That means my overall equivalent resistance will be 10 ohm. Clear? So we have done with the parallel resistance also. We have parallel as in the two. Now that means my this equivalent part resistance will be how much? 8 ohm, and this circuit will behave like 10, this part of the circuit 10 ohm, right? That means if we convert them into series, that means this will be 8 ohm and this particular portion will offer 10 ohm. Now what is my total resistance? 18 ohm. Clear? So total resistance is 8 plus 10, 18 ohm. Next, total current flowing in the circuit. Total current flowing in the circuit means voltage we have total current, no, I equals to V by R. So how much is my V? 12. How much is my overall resistance? 18. Again the same story, it will divide 0.0, 3 6 are 18, again 0 6. That means my overall current will be 0.67 ampere. Clear? See, till understanding the circuits and everything is physics. After that it's maths. So I don't think so. Yeah, definitely I'll guide you, but still this you need to be faster. Okay, fine. Finding the equivalent resistance of this part of the circuit, then you are finding. So once we make them a single unit of resistance, now how are they joined? Series. So that's how we have found out. Clear? Next. Okay, calculate through. Okay, so this is a resistance that we have 5, 10, 30 and this is 12. Okay, calculate the current through each resistor. Okay, calculate what? The current through each resistor. Now we have to find it out. Okay, so such kind of questions, overall you have to find out the equivalent resistance. Again the same story, parallel combination. Parallel combination, 1 by 5 plus 1 by 10 plus 1 by 30. Okay. So equivalent resistance is what? 6 plus 3 plus 1. Fine. So now my equivalent resistance is how much? 9 and 10. So 3 ohm is my total equivalent resistance. Okay. Now we have to find out total current in the circuit. Okay. First, total resistance in the circuit we have found out 3 ohm. Is it clear? Very easy. No, this was very simple. Okay. And then total current. Yeah. Total current, that means we are solving from back. So total current is what? V by R. So what's my voltage? 12. What's my resistance? Overall resistance 3. So that means 4 ampere. Okay, last question, that means the first question, current through each resistor. Okay, so we know here in parallel what is same? V is same. So that means we have to find out with I1. I1 is equal to V by R1. So what's my voltage? 12. So 12 by 5. I2 will be 12 by 10, that's 1.2 ampere. This will be 5 2s are 10, then 2.4 ampere. And lastly I3 12 by 30. 2 6 are 12, 15, that means 0.4 ampere. Clear? So that's all. So total current in the circuit now will be, okay, total current in the circuit is 4 ampere. It's fine. Now through each and every resistor we have found out, that is this is 2.4 ampere, 10 10 10 10, it's 1.2 ampere, and 30 will be 0.4 ampere. Can you see, as your resistance is increasing, the current is also decreasing. Now what's my overall resistance? Let me check whether it's coming 4 ampere or not. 2.4 and 1.2 is how much? 3.6, 3.6 and plus 0.4 is 4 ampere. Did you understand? This is how we need to go through. Next. Okay. Next question, what is the combined resistance? Again the same story. See, after all, it's easy, okay. Once you start, solving variety of questions, it will look simple only. It will not look complex. Okay. So overall voltage we don't know, just the current they have given 6 ampere. That means total current they have given as 6 ampere, right? Now we have to find out the total resistance as well. Means R equivalent resistance will be 2 ohm. Clear? That means we have found out what is the combined resistance, which is 2 ohm. Clear? Next, that means if we can find out the overall potential difference also, then that is 6 into 2, that's 12 volt. That means my overall voltage is how much? 12 volt. Clear? Okay. So is there any question as such? What is the overall potential? What is the potential difference across the combined resistance? Yes, it's there, 12 volt. Fine. Next question, what is the potential difference across the 3 ohm resistor? So if you see what is the potential difference across the 3 ohm resistor, it will be 12 volt. Why? Because they are connected in parallel. Fine. What is the current in the 3 ohm resistor? Now in this case, what is the current? It will definitely not be 6 ampere, it will split. So that means we have found, because that means we can easily find out, that is current through 3 ohm. Okay, that means V by R, what's my voltage? 12, and 3 is the given resistance. So that means 4 ampere. So 4 ampere is the current that will be where? Current through 3 ohm. That means my current that will be drawn is 4 ampere. Clear? That means definitely if this is 4 ampere, this will be 2 ampere. Let's check how much is the total voltage. 12. Let's say this is R1 and this is R2. Okay, 6. How much did I say? 2, I told, no, 2 ampere already, because your total 6 ampere current was flowing. Clear? So what is the current that is present in 3 ohm? 4 ampere. Clear? Next question. Let us see. The figure given below shows an electric circuit in which the current flows from a 6 volt battery through 2 resistors. Are the resistors connected in series with each other or in parallel? So definitely if you see, the current starts flowing from here. So if you see the current will flow from in this direction. Once the current comes here, don't you think there are 2 options? That means they are connected in parallel. Clear? Okay. For each resistor, state the potential difference across it. For each resistor, you need a potential difference. That is definitely, the pen was destined to fall. Anyways, so for each resistor, state the potential difference across it. That means it will be 6 volt, 6 volt. Why? Because they are connected in parallel, and we know the struggle is same in both the cases, both the roads. Okay, that means it will be 6 volt. Fine. So this is all. Next, the current flowing from the battery is shared between the 2 resistors. Which resistors will have a bigger share of the current? That means we know more the resistance, less is the current. So which resistor will have bigger share? Bigger share of the current means less resistance. That means this one, 2 ohm. Calculate the effective resistance of the two resistors. Okay, so D we will solve. That means my equivalent resistance will be 1 by 2 plus 1 by 3, which is 3 plus 2, that's 5 by 6, right? So my equivalent resistance will be 6 by 5 excuse me. That means it will be 1.2 ohm. Clear? Fine. So my equivalent resistance is 1.2 ohm. Now that means my this is done, D is already done. Next is E. Calculate the current that flows from the battery. That means we have to find out the common current. How we have to find out the common current? That is V I equals to V by R. Clear? That means V is how much? 6, and resistance, overall resistance is how much? 1.2 overall resistance. I just eliminate this 10. So 6 2s 5. So that means 5 ampere. Fine. So the current that is flowing through the circuit is 5 ampere, and then it gets speeded up. Calculate the current that flows from the battery. Okay, so the current that flows from the battery will be how much? 5 ampere. Are you able to understand this part? Calculate the current that flows from the battery. Is it fine now? Clear? Then you can, now since we know the overall voltage and this one, so we know here it will be how much? 3 ampere. Here it will be how much? 2 ampere. So overall it makes up 5 ampere. Okay. So you understand these things are very simple. You just need to keep this thing in mind. In a series, okay, chalo, my current will be fixed, voltage will be different. It's parallel, okay, voltage is different, voltage is same, baki all different. So one of the factors will remain constant, then only the other two can play. If two of them are fixed, that means the third person also needs to be fixed. Okay, next. In the diagram shown below, the cell and the ammeter have negligible resistance. The resistors are identical. Okay, all of them have the same resistance. Okay, not a problem. Here also it's R, there is also R, here is also R. Fine. Okay. Now both have them negligible, the resistors are identical. Okay, so here we can say almost the resistance of ammeter is almost 0. Okay, with the switch key open, that means it's open, the ammeter reads a current of 0.6 ampere. What will be the ammeter reading when the switch is closed? Okay, so first thing you see, when the electrons will flow from this direction, maybe the current will flow from this direction, it will see these two routes and it will try to complete them. Fine. So initially you have to find out like this. Initially when my switch was open, that means it was reading, how much current was reading? 0.6 ampere. That means my total current is how much? 0.6 ampere. Let's say this resistance is not present. Okay, and my voltage, so I don't know what's my voltage. Okay, I'll find it out later. Now my overall resistance, that means my overall resistance will be 1 by R plus 1 by R, which means 2 by R. That means my equivalent resistance will be R by 2. Clear this much? Okay, so since it's my R by 2, my voltage is definitely the same, right? It is definitely the same. Just remember one thing, 0.6 ampere is the current that is flowing from this part. Okay, now splitting is definitely there. Voltage, okay, so first of all we have to understand various points here. What they have asked, what will be the ammeter reading when the switch is closed? Okay, now voltage, let's say voltage is V. What else they need? Okay, see, now the ammeter is measuring how much current is passing. What will be the ammeter reading when the switch is closed? Fine. That means yeah, definitely we have to see how much current is definitely flowing. So when my equivalent resistance is R by 2, then my I is how much? 0.6. That means my voltage will be how much? Because we know in this case voltage is same. So 0.6 into R by 2. That means 6R by 20 volt. Clear? Understood? Okay. Next, that means this is my overall voltage, yes or no? This is my overall voltage, because we know the current is drawn is 0.6, where is it? 0.6 ampere, and we have found out the equivalent resistance with the true resistance, and this is what, that means my voltage is constant. That means this will be my voltage in this case also, when my this is now closed. Now my equivalent resistance will be how much? 1 by R into 3, that is 3 by R. That means my R equivalent resistance will be how much? R by 3. Very good. Now what we will find out? We will find out what will be the current reading. I is equal to what? V by R. So what's my voltage? 6R by 20. And what's my present resistance? R by 3. So 6R by 20 reciprocal, 3 by R gets cancelled, and it's 2 3s means 2 10s and 2 3s. So that means 3 3s are 9, 9 by 10, that is 0.9 ampere. So the reading that will be given is 0.9 ampere. Okay, I repeat how I have solved this question. So first, see, we don't know the value of voltage also, we just know the ammeter reading. So first, when this key was closed, that means this circuit part is not complete, but other two circuits are completed. That means we have to find out the equivalent resistance of these two resistors. We have found out that is R by 2. Now we know in this case what was my reading? 0.6. So 0.6, that means I into R, right? I into R. So 0.6 into R by 2, that means it is becoming how much? 2 tenths are 20 and 6. That's what I am trying to say is IR. No. What's my I? 0.6. And what's my R? R by 2. So that means 10. That means it is becoming how much? 6R by 20 volts. Clear? Now this, how many, you can add any number of resistors, because after all, when you try to make a circuit, your potential difference is fixed. Now you can add many number of circuits, you know the voltage is fixed. So that means this is the same voltage that I have put forwarded here, 6R by 20. And what's my resistance now? Since this is closed, that means this is closed, that means we have to consider the third resistor as well. That means it's 3 by R, R by 3, anyways it gets a reciprocal. And then we saw that how much amount of current is being drawn by this overall circuit, that is 0.9 ampere. Clear? Okay. Thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel Vigyan Jyoti, hit the like button and share it with your dear and near ones. And yes, please don't forget to comment, because your feedback does matter.